Around 4.6 billion years ago, the place where our solar system now exists was just a vast cloud of gas and dust, remnants of an ancient exploding star, a supernova dot. This cloud, called the solar nebula, slowly began to spin and collapse under its own gravity dot. At the center, pressure and temperature rose until a new star was born, our sun dot. If you like similar educational content, please like, subscribe to the channel, and share the video with your friends. In the outer, cooler regions of this swirling disk, small pieces of rock and metal began to collide and stick together. Over millions of years, they formed larger clumps, planetesimals, the embryos of planets. One of these bodies, orbiting in a perfect zone between heat and cold, began to grow quickly, its gravity pulling in more and more material. Every collision released huge amounts of heat, turning the young Earth into a molten ball of lava and metal. At that time, the surface was a red-hot ocean of magma. Volcanoes erupted endlessly, releasing steam, sulfur, and carbon dioxide. There was no air, no oceans, and no life, only chaos and fire. The collision that changed everything about 50 million years after Earth's formation. A Mars-sized body named Theia struck the young planet. The impact was catastrophic. Part of Earth's crust was thrown into orbit and later clumped together, forming the moon. This single event tilted Earth's axis, stabilized its rotation, and created the conditions for the future cycle of day and night. After the collision, Earth melted again from the released energy. Heavy elements such as iron and nickel sank to the center, forming the core, while lighter materials floated upward, forming the crust and atmosphere. The planet slowly began to cool, and that cooling changed everything. After millions of years of violent impacts and eruptions, Earth finally began to calm down. Its surface was still covered with molten rock, but slowly the planet started to cool. Volcanoes kept spewing gases, steam, carbon dioxide, methane, and ammonia, forming a thick, toxic atmosphere. There was no oxygen, only darkness and heat. As the surface temperature dropped, the water vapor in the air began to condense. And then it started to rain. Not for days or years, but for millions of years. Raindrops fell endlessly, hissing on the hot surface and turning back into steam, until finally, the crust cooled enough for water to remain. The first oceans. Those endless rains filled lowlands and craters, creating the first oceans, hot, acidic, and full of minerals. They became the cradle of life. The blue planet was beginning to take shape. At the same time, gases from volcanic eruptions thickened the atmosphere. There was still no oxygen, but carbon dioxide and methane trapped the sun's heat, creating a natural greenhouse effect that kept the planet warm and alive. Ironically, what we now call a danger, global warming, was once the reason Earth didn't freeze solid. Water from space. Some scientists believe that part of Earth's water came from inside the planet, from gases released as the interior cooled. But many others argue that it came from comets and asteroids made of ice. When these icy bodies slammed into Earth, they released vapor that later condensed into water. No matter where it came from, that water changed everything. It shaped the surface, cooled the crust, and provided the medium in which life could begin. The birth of continents and natural cycles. As Earth cooled, its surface hardened. Lava flows formed islands and early continents, which constantly moved, merged, and broke apart due to tectonic activity. Wind, rain, and erosion began recycling minerals and elements. The first planetary cycles of carbon, nitrogen, and water started to operate. The planet was becoming self-regulating, a dynamic system preparing for the next great leap, the emergence of life. The first chemical sparks in the depths of the oceans, where heat and chemicals mixed. Simple molecules began to combine into more complex ones. Lightning strikes, volcanic energy, and radiation triggered reactions that produced amino acids, proteins, and the building blocks of DNA. From chemistry, biology was born. The lifeless planet had just begun to stir. Roughly 3.8 billion years ago, Earth was no longer a blazing inferno. It had oceans, a thick atmosphere, and enough stability for something extraordinary to happen. Life began. From chemistry to biology, in the warm oceans rich in minerals, simple chemical compounds started to react. They formed more complex molecules such as amino acids and proteins, the fundamental ingredients of life. At some point, certain molecules gained the ability to replicate themselves, perhaps using early forms of RNA, capable of carrying and copying information. We don't know exactly where it happened. It could have been in deep-sea hydrothermal vents, where mineral-rich water met volcanic heat, or in shallow tidal pools under the lightning-filled skies. But one thing is certain, at some moment, non-living matter organized itself into life. The first microorganisms, the first cells were simple, tiny, and tough, bacteria-like organisms that didn't need oxygen. They obtained energy from chemical reactions using sulfur, iron, and hydrogen. These were the pioneers of life, thriving in extreme conditions, boiling water, acidic seas, and total darkness. Over time, they colonized the oceans, forming layered microbial structures known as stromatolites, the oldest fossils we've ever found. Through them, life began to shape Earth itself. The oxygen revolution. After hundreds of millions of years, new microorganisms evolved, the cyanobacteria, capable of photosynthesis. They captured sunlight and turned carbon dioxide and water into energy, releasing oxygen as a byproduct. At first, oxygen was toxic to most existing life forms. But it slowly began to accumulate in the oceans and atmosphere, turning the planet's surface red as it reacted with iron in the rocks. This was the Great Oxidation Event, one of the most dramatic transformations in Earth's history. Oceans filled with oxygen, the sky turned blue, and life was forced to adapt or die. But this change also made it possible for complex organisms to evolve, cells with nuclei, called eukaryotes, which became the ancestors of plants, animals, and humans. Life reshapes the planet. The interaction between living organisms and the environment became stronger. Photosynthesis balanced gases, volcanic activity recycled minerals, and the biosphere began to regulate the entire planet. Earth became a living system, where every drop of water, every breath of air, and every grain of soil was connected to the rhythm of life. The blue planet was now alive, not just chemically, but biologically. After billions of years of silent microbial life, something incredible began. Earth entered an age of transformation. Multicellular life evolved. The oceans that once held only bacteria and algae became crowded with creatures of all shapes and sizes. The Cambrian explosion, life's big leap around. 540 million years ago, evolution accelerated dramatically. In what scientists call the Cambrian explosion, life diversified at a breathtaking pace. The first complex animals appeared. Creatures with eyes, skeletons, and nervous systems. Predators and prey began their eternal dance. The seas filled with trilobites, sponges, and early fish. Nature discovered complexity, and evolution became an unstoppable creative force. Life conquers the land. Roughly 400 million years ago, plants began to spread across the land. They anchored themselves in the barren rock, creating the first soils and releasing more oxygen into the air. Soon, insects, amphibians, and reptiles followed. Earth turned green for the first time. These vast forests captured carbon dioxide, locking it underground and forming future coal deposits. The balance of atmosphere, water, and life continued to evolve, a planetary symphony that has lasted for eons. The age of giants and mass extinctions, then came the age of reptiles, the reign of dinosaurs. For over 150 million years, these giants ruled the Earth. But nothing in nature lasts forever. About 66 million years ago, a 10-kilometer-wide asteroid struck near what is now the Yucatan Peninsula. The impact unleashed energy equivalent to billions of nuclear bombs, filling the atmosphere with dust and blocking sunlight for months. Temperatures dropped, plants died, and the food chain collapsed. The dinosaurs, once masters of the planet, went extinct. Yet from their ashes rose new forms of life, mammals, small and adaptable, ready to take over a changed world. The rise of humans. From those early mammals evolved primates, and about 2.5 million years ago, the first Homo species appeared. They learned to use tools, control fire, and communicate. Over time, their intelligence expanded, and with it came art, language, and civilization. Humans became the first beings capable of understanding their own origins, looking up at the stars and wondering, where did we come from? A thinking planet through billions of years, Earth turned chaos into order, dust into life, and instinct into consciousness. Now, the planet itself, through us, has become aware. We are the voice of a world that has learned to think. But with that awareness comes responsibility. Human activity is changing the climate, reshaping ecosystems, and testing the balance that life has maintained for eons. Our future depends on whether we can protect the system that created us. Earth was born from fire, sculpted by water, and awakened by life. Every atom in our bodies was once part of a star that exploded billions of years ago. When we look at the night sky, we are not just observing the universe, we are looking at our own origin. Planet Earth is more than just a home. It is living evidence that the universe can create, evolve, and understand itself. And as long as we exist, the story of Earth continues.